Hello everybody and welcome back to another video. My name is Cameron Mackenzie and today I'm going to be taking us through extending our capabilities within Autodesk Fusion. So the main objective of today is to give a broader understanding of the capabilities that are available within the product itself. So in our previous video we had a look at some of the base functionality that is included in the default installation, the base installation of Fusion. Today we're going to be looking at some of the extensions that are available to us. So you can see on screen we've got 5 different design extensions or extensions available to us within the product itself. We've got a design, so Fusion Design, we've got Fusion Manage, Manufacturing, Signal Integrity, and Simulation. These offer a huge range of additional capabilities on top of your designing capabilities within the product itself. We're going to be looking specifically today at the design, manufacturing, and simulation packages, but we've also got the ability, as you can see here, to do some additional management of our components, of our product life cycles, as well as doing some PCB design using signal integrity as an extension. So within the design environment, we've got a few design-specific tools that are available to us, predominantly within the plastics manufacturing side of things, plastic design, but we do have some capabilities within the design that filters out through our other design elements as well. When it comes to manufacturing, Fusion have now packaged all of the manufacturing capabilities, extension capabilities rather, within a single unified manufacturing extension. So this covers a huge range of manufacturing options that are available to us, including nesting and fabrication, as well as the traditional 3D printing options that we would see inside of Fusion, as well as our subtractive manufacturing. So all of the multi-axis and 5-axis strategies that we're familiar with within Fusion, or most of us are familiar with within Fusion, they're now all sat within a single overarching manufacturer extension. We've also now got a unified simulation extension, which is going to encompass all forms of simulation, whether it be linear static stress, whether it be fluid dynamics, whether it be injection molding, whether it be generative design, and so on. We've got the ability to, in a single package now, use all of the different solvers and be able to use unlimited studies from within there. So all nice and neatly packaged in the different extensions that you might want to be able to use throughout. So we're going to take a quick look at a high-level overview of a lot of these tools, and we might get into a bit more depth in some of the more specific options that are available to us. So I'm going to start off within the design extension options that are available to us. Now, inside of this model, I've gone in and created a fairly simple component based on a really nice capsule I've seen around a few times. And want to now convert this particular component into something that is manufacturable and starts to create a bit of a rule set. So within the plastic tab, within the design environment, again, this is the design extension giving us extra design capabilities. We've got plastic manufacturing or plastic creation options available to us from within here. And a few of the tools that are available to us are some automation, some automated modeling options. So we've got the ability to very quickly go in and create bosses, and those will include the fasteners with them. We've got snap fits that we can come in and add in here, as well as the ability to create lips that's going to subtract geometry as well as adding any required geometry along the way. What's also really nice with the plastic modeling tab is we've got the ability to go in and create rules for the plastic components that we're designing. So we've got against each of these 2 components over here a plastic rule which can easily be assigned within the setup tab. So hitting assign will allow us to then go and choose a component that we want to apply a rule set to, and we can go and choose from a library of materials that are available to us. And this can be all configured as well as to the thickness of the material, the nominal thickness, what the physical material itself will need to be, as well as any minimum draft angles and draft angles, minimum radius, nominal radius, and so on. So against every single one of these components, we can then start to build up a rule set as to how the model needs to be, first of all, designed in order for it to then go and be manufactured. So with those rules in place, I've got the plastic ABS rule 2mm in place at the moment against both my components, so the component that's inside of my capsule within the body over here, as well as the component. I've got a second component just to allow some motion between these two to create this nice joint over here. Now against each of those two components, I can start to then add a bit more detailing. So I've got the main shell of the component, I've got the main estimated external geometry in place already. I want to then go and assign a rule set to it, which I've gone in and assigned that to more ABS. I can then start to use some of the modification tools and creation tools to then start bringing out all of that information, all of that data. So if I were to very quickly go in and create a shell against the component, I can go and select this bottom part over here, which is part of my main component. And immediately it's gone in and picked up that thickness value, which is being driven by that ABS plastic rule for me. So I don't have to go and enter a value in. If that rule ever changes in thickness and size, this will then update this as well. So it's automatically gone and grabbed an inside thickness value for me. So all I really need to do from here is hit OK and apply that in. Nice and simple against each of those two sides. Another option we have available to us is when we are creating any drafts. So if we go into the create panel and go and grab and place any drafts in, sorry, not the create panel, the modification panel instead. If we wanted to go and create any drafts against surfaces, they will also automatically go and pick up the draft angle that is specified inside of that. This particular one, I don't have a draft angle on or any surfaces that I would want to add that into, but you've got a very quick way of then just applying certain details on there as well, and this will then keep to the rule set that you've created. That will also include fillets. So if I go and grab a fillet and add a fillet to the external surface over there, I've got a nominal radius that it then wants to go and apply immediately to that corner. In this case, it might be a little bit small, so I can use the equation to then go and place in a nominal radius that's half of that value, or any other fractional value of that nominal radius. So that really goes in and helps us, assists us in the creation of certain features from inside of the design environment. We've also then got some automated modeling sides to the product design extension. So we've got, or rather the design extension, so we've got the ability, as I mentioned before, to create bosses and snap fits. These are each driven by sketches, so sketch points within the model itself. I've got one in the background over here somewhere. This one over here seems to be the one. And you can see I've got a small node, a small point in the sketch itself within Sketch 2 that I'm going to use as a reference for the location of my snap. If I go and grab the snap fit option from within the create panel, it'll go and immediately place a snap fit exactly at the point at which I've selected over there. And we've got different configuration options available to us, whether we want a parallel hook and groove, whether we want a perpendicular hook and groove, or whether we want a hook and loop instead. So depending on the type of geometry we're wanting to make and connect to each other, we've got the ability to go and make use of each of those two. If I decided I wanted a hook and loop, I can go and grab hook and loop from here, rotate the angle of the hook itself, and you can see how it's now going to be adding that in to my geometry. Now again, depending on where I want this located, that's all going to be driven by the sketch itself, and then it's also at this point in time going to be cutting through the top component and whilst adding geometry to the bottom component, so we can go in and simultaneously add and remove geometry from the two. If I hit OK on there now, it'll go in and create that geometry for me, so that I've got that hook on the inside, and then I should have a clip on the inside as well of the top surface. I might need to go and adjust the positioning of that ever so slightly. I can see that the hook itself is on the wrong side, so let me just go and edit the feature, rotate that around 180 degrees, to -90, and we can see that that's now gone and created the clip for me there, as well as the hook down below. So I've got two components that have been designed to fit nice and neatly together, and I've got the positions at those 2 points over there. If we decided that we wanted a boss in there as well with a fastener to keep things nice and closed, maybe instead of a hook and clip, I could go in and remove that one or suppress it, and using the same sketch, although I might alter the sketch ever so slightly, we've got the ability to go in and modify that so that we've got an appropriate position for that hole over there. Let me just go and remove that very quickly. Let me edit sketch from within here. I've got a 38mm dimension. Let me just drop that down to something a little bit more towards maybe 30 or so, somewhere along there. Finish sketch just to get it off the side ever so slightly. And then using the boss tool, I can go use the boss tool, capture the current positions of the two components, and add my boss in over there. Using the boss tool, I can then, based on the position of that point within the sketch itself, I can either then offset either in the Y or in the positively or negatively, depending on my modeling direction. Or I've got the ability to, as well, if I wanted to, go and adjust the sizing of that boss as well, or rather the fastener, which will then drive the diameter of the boss as well. Got a whole range of options that are available to us from here, from the fastener, whether we want one or not, to its head type and drive and so on, to its threaded angle, its diameter, length, and the like. We've also got the ability to go in and choose whether our two components are being cut. So are we only creating the boss on one side or the other? And based on the two that we are cutting, what is the type of hole that we're creating at this time? What is the step type between the two, and so on. If I did want to add any structural rigidity by adding in ribs, I've got the ability to go over to the ribs tab and decide whether I want ribs on one side or both. And if I do want those in there, what is the configuration of that? I've got the ability to choose between 1 and 3 ribs if I wanted. 1 and 4 ribs on either side. I can choose the profile shape. I can choose the angle of rotation around the central axes, and a whole range of other options available from within there. If I OK that now very quickly, we'll see that the geometry is now created against both components. So I've got the ability to open this up, and I can see the fastener on the top half and the boss on the bottom half over there. And that's all using the settings that we've created for the rules behind the plastic component itself. So really powerful tool that's going to allow us to very quickly go in and model those in as well. Another really nice one that we've got available to us is the ability to create a lip. So wherever we want the two faces to come and meet together and have a bit more of a tighter fit together, we've got the ability to go in and create a lip. Again, I'll go and capture the current position of these two components and then choose the face that I want, or the edge that I want the lip to take place on. I've also got the ability then to choose whether I'm only creating a single lip, whether I'm creating a groove on the opposite side, or whether I'm creating both of them at the same time, a lip and groove. And then I can go and choose the guide type, the direction in which we want to have this created. So for the pull direction, I'll go and choose this face over here. And you can see it will now simultaneously go and cut and add geometry against each of those two. If I wanted to go and tweak exactly how that's being created, I've got the advanced tab over here where it's going and grabbing the thickness, dividing it by 3 for our A dimension, which is the depth. We've then got the width of the lip itself at its base, and that's the same value. We've got a value for C, which is then the offset from the inside, and a few other dimensions along here, including the draft angles for the lip itself. So all of that information is directly inside of our setup. As soon as I hit OK on there now, that should then go and cut into the top piece and also do a bit of a cut on the bottom piece while simultaneously adding geometry between the two. So once we've got that all nicely configured, we've then got the ability to add any other final detailing to this model. One of the extra ones that we've got available to us also within the design extension is the ability to use a geometric pattern. So what a geometric pattern will do is it'll take a surface, any surface on your model, and allow us to then go and add a pattern to that. So it's not just a normal rectangular, circular, or path pattern. This one will allow us to go and create varying sizes in the objects that we choose. So we can either choose from standard objects, a sphere, cylinder, or box. I'll go and grab a sphere for this one. We could choose then the size range. What is the smallest one going to be and what is the largest one going to be? If I remember correctly, this one was around 2 millimeters. Fits nicely on here. I might want a slight variation, so I'll go between 2 and 3, and you can see how the smaller ones are currently on the inside and the larger ones are on the outside, and we can change the dispersion of this or the spread of these as well as to which sides or how it moves forwards and backwards. A 50 or 0.5 spread will usually, or rather 0 spread, will have a nice even spread across the component. We can also then go and choose the shape of the distribution itself. So whether we want a squared distribution, we want rows and columns, or do we want a triangular or hexagonal or a radial on the component itself. And we can also then go and increase for radial the number of radians that we want to go and grab as part of that process. Quite like the circular one on this one. And we've also got the ability then to go and clear the perimeter. So if we don't want the items making contact with the perimeter of that surface, we can just hit OK, and we've now got a pattern of those shapes. Now at any point in time, it's just a feature at the end of the day, so we can go in and modify those, and whether we wanted to change the shape, whether we wanted to create our own custom shape, or we wanted to change how that's created. Instead of bumps on the surface, I might want to have dimples in there, so I can go and cut that out, hit OK, and that's now going to cut that pattern out of the surface rather than adding it to the surface. So all depending on the type of surface we're wanting to use along the way. The next area I want to have a look at, a bit of a continuation really from the last webinar we had. So in the last webinar we had a chair, and we've got the ability to configure the different legs on the chair itself, and be able to change materials and so on with the configurations. When it comes to our simulation environments, we've got the ability to create various studies against these components just to make sure that when we are changing these sizes, we are getting the results we're expecting. The components will be able to withstand the loads that we apply to them. So we've got this leg base over here that we used in the previous example, and we've just gone and quickly created a simulation against that just to ensure that it is going to be able to handle the load that is going to be applied to this one. So if I go into my simulation over here, we've got the ability to create multiple different study types, but for the sake of this one, we've gone and used a static stress, but the other studies that are available to us within the Fusion simulation environment, we've got modal frequencies, we've got electronics cooling and thermal, we've got thermal stress, which is then going to be able to define after a series of thermal changes what the stress on our components will be. We've also got structural buckling, injection molding simulation, if again we're working with plastic modeling, as well as shape optimization and a few others from within the list as well. So for this particular one, I've gone and done a static stress, but these are the other options that are available to us as well. So on this one, we've essentially gone in and said that we've got a certain component that needs to remain fixed in place, and we want to apply a load against the other side of the component itself. So I've gone and taken this top surface over here, told it it needs to remain still, and applied a load of 500 newtons, about 50 kilograms, to the bottom of the leg itself, as if the leg was pushing up into the component itself. Now, from the actual design itself, we've got about 3 legs, at least 3 to 7 legs, or 3 to 6 legs around the component itself. So we can then essentially multiply that force by the number of legs around, just to be able to withstand. So we want to try and grab the fewest number of legs and be able to ensure that our chair will be able to withstand that force. So we've got the load case all set up, and the results are in for here. So I'll just go into the result itself, and I can see now against that we've got our force is applied against that wheel, or the wheel connector, and we can see that force is actually pushing the component up ever so slightly. Now this is a slightly exaggerated version of it, just so we can see the force itself. But what I can see from here is I've got more than 8 times safety factor. So this is more than 8 times stronger than we really require for the sake of passing this particular component. What that obviously means then is we can then start to reduce material if we wanted to, save a bit of weight on the component, save a bit of material on the component itself, and be able to produce more out of that. So we've completely over-engineered this particular component, probably also because I've made it out of cast steel, but we've got the ability to come in and run the simulation against multiple different materials to be able to get a good determination as to what the requirements are in order to get this to pass its test. As well as being able to see the safety factor against the entire surface of the component, we can also come in and analyze the highest areas of stress. So if I go to the stress view over here, I can see that naturally the area that's going to see the most amount of stress is going to be right underneath the component, where it's going to be pulled away from the material. We've also got the ability to see how much displacement there will be in real terms, and where that displacement is going to be taking place. So we've got absolutely nothing at the top where it's fastened, all the way down to our maximum, which at the moment is 0.487 millimeters. So we've got more than enough on there. If I go and change the deformation against this one to actual deformation, we can see it's minuscule with 50 kilograms on one leg. We've got the ability to then use this to analyze different areas, so we can show where the minimum and maximum are in each of these views. So reaction force, if we were using that, what the strain would be, and where the maximum and minimum were, and any other views we've got the ability to always show the minimum and maximum. We've also got the ability to create probe points, so if we do decide that we want to analyze a certain portion of the surface at all times in all the different views, we can then ensure that probe point is going to remain there, and it's going to give us a readout against each of the different views. So we can see that is 15 times stronger than the safety factor, or rather it has a safety factor of 15. On top of that then, if that is the case and we want to then start reducing material, we looked previously at the automated modeling side of things, but we've also got the ability within the extension, within the simulation extension, to then go and run generative designs against these components. So using generative design, what we want to do is similar to the automated modeling. We would then have an area that we want to, or 2 elements that we want to connect together. And we've got areas that we might want to avoid. We've got red areas, which are obstacles. So we assign preserved geometry, and we assign obstacle geometry. And more recently, we've got the ability as well to assign a line of symmetry. So if you do want your model, once it's generated, to look nice and symmetric, we've got the ability to go and apply a line of symmetry, which I've done in this case. So for this one, I've gone and applied the line of symmetry right down the middle of the part. And then I've gone and said I want to keep the bowl where the seat is going to be located, and then I also want to go and keep the cylinder where the wheel is going to be fastened, and then between those two, or inside of each of those, where the actual wheel is going to need to be connected, and where the seat is going to need to be connected, I've created those as a void or obstacle geometry, and then left everything else as is. We then also go and say, well, much in the same way as a bit of a combination, I suppose, between the automated modeling and our simulation study against the linear stress, we go and say, well, we want a certain area fixed and another area needs to have a load applied to it. And then based on those criteria, based on the manufacturing methods we have available to us, we can go and establish a model that can be created as part of the process. So if I go into my objectives, I can go and choose what the objectives are. Do I want to maximize the stiffness? And therefore I want to have it as stiff as possible with all the way up to the safety factor itself. Or do I want to go and minimize the mass? So it's going to go and start with the bulkier component and then bring down the mass as much as possible until again you reach that safety factor. We've also got the ability to choose what the displacement is, what the allowable displacement is within the region itself, and whether this be global or local. We also have the ability to decide what the safety factor will be for buckling against the component rather than just a displacement. We also want to go and grab buckling as a factor. We can then go and assign manufacturing techniques against this. So in this case, I've gone for an unrestricted one just to see what shapes we do manage to get out of it. But we've got the ability then to choose additive or milling. And from those, we've got a few extra options. If we are using milling, we can go and choose between 2.5, 3, and 5 axes. And based on those setups, we've got then the ability to choose the tool direction for each of those. If we choose a 5 axes, we've got the ability to choose what the maximum minimum tool diameters are, what the shoulder lengths are, and what the head diameter is. And we've got 2 axes cutting as well if we wanted to, if we are, depending on our manufacturing capabilities, as well as die casting. Once you've got all of that configured, you then go and send this up to the cloud. It will then go and compute the model for us and be able to give us a result. This can take quite a while to do it. So we've gone ahead and run a study beforehand, and we can just have a very quick look at the results directly from inside there. So once that's all configured and ready to go, we can go and hit explore. And this is going to give us a list of all of the results that are available based on the setup that we've required. So I can see against this one, I've gone and applied the same 50 kilogram load against the component itself, or against the leg itself rather. And these are the results that we've managed to get from those. So if I go and look at this one, and it breaks these lists down into our recommended results and anything that is converged, anything that has finished the study and matched the criteria essentially that we want. And I can see very thin components in here. So this, we could probably go in and bump up the load against that, maybe double it or even more, and we'll be able to get a bit more of a thicker component essentially generated throughout the process. But if I go and select this one over here very quickly, I can get a nice preview of the component itself, and I can start to have a look at the different results that have come through based on the inputs I've given it. So in this case, I've gone for a titanium material with an unrestricted orientation using a 5-axis milling process. It'll go and give me what the von Mises strength is against or stress rather is against them, what's the maximum displacement, what buckling safety factor we've reached, what the buckling factor of safety, wow, what a mouthful, is available to it, or it would be able to withstand, and so on. We can also go into our stress view here and see any high areas of stress. In this case, this one's been designed to go all the way up until it reaches any form of stress, and therefore we should be low on everything. We've got the ability as well during this process to go and compare between other results. So I can go and say, well, I want to go and compare between this one, and I can see then between these two, this one has been designed for 3-axis milling, whereas the one on the left-hand side has been designed with 5-axis milling in mind. So we've got the ability to then go and compare what these two would look like next to each other, and see which is the more realistic or which one is more feasible from a creation standpoint. Once we've decided on a model, we can then also go and see from this view where the preserved geometry is currently located within the existing model, and where the obstacle geometry is, just to sort of visualize how this would connect if it is quite an abstract component itself. But from here, we've got the ability then to go and export these out depending on the results that we want. If we find anything, a model that we want to then go and grab from here, we've got the ability then to go and create a design from the outcome, or a mesh. If we wanted to print this off, we've got the ability just to use a 3D mesh directly from inside here. So whether we want a component or a mesh, we can go and grab directly from inside of this list. So again, I've gone and grabbed a design from this one. So I'll go and hit finish component and go into this generative leg over here. And this is one of the results that we managed to get out of the component. So as soon as we've completed that, we get this lovely model available to us. And we can actually see with these models that we do get from the generative design is they're fully editable as well. So not only can we use this as a bit of a reference if we wanted to just take the profile of the component, put it into a sketch, trace along it, or even use an intersect to get all of the nice edges along there and just create a 2D profile out of it. Or we've got the ability to go in, and this is going to use the organic mesh modeling to create this component for us. So we've got a mesh, an organic mesh directly from inside of the model itself. By double clicking on here, I can go directly into the mesh itself and start to modify that. So if I wanted to make some simplifications to this, I might say, well, actually, some of this geometry, we know that this thing is a lot stronger than it needs to be. So we could either go in and remove some geometry if we're feeling confident in the way we are removing those, or we can maybe make some of the components or some of the edges a little bit thicker and neaten others up a bit. So I could go in here at any point in time and go and grab any of these edges. I can go and grab the entire edge loop over there and make the loop a little smaller, adding a bit more geometry to the component itself, adding a bit more material to it. I can go and grab these edges over here, and because I told it to be symmetric, it's automatically gone and created a line of symmetry between the two, whereby I can go and thicken this component by dragging those edges out ever so slightly and maybe up a little bit as well. Or I can go and shrink them in any direction to make the surfaces a little thicker. So using the model that has already been created for us, we can go and make any final modification, any final tweaks we need to the component itself. Once we're happy with that, we can go and hit finish form. And that's now a solid that we can make use of. So directly editing the solid geometry along the way. And then another side of the, or another extension rather, that's available to us that we'll take a look at, this is the last one we'll take a look at, quite a detailed one as well, is the manufacturing extension. So within the manufacturing extension, we have different manufacturing options available to us. So traditionally, these were separated into their own unique extensions, but we now have all manufacturing options available within a single unified space. So the two areas we're going to look at today are nesting and fabrication, as well as the milling options, the advanced milling options available. So if I just take, for instance, this cabinet over here, previously we would have to go in and create our own configurations and try and fit these components nice and neatly together if we want to get a nice cutting profile out and try to optimize on each sheet of material, whether this be wood, whether this be sheet metal, or any other type of material that you're making use of. With a uniform thickness. Now what we've got the ability to do using the nesting functionalities within the manufacturing extension is if we go into the utilities tab, we've got the ability to configure the nest preparation directly inside of the assembly model. So we can make use of all of the individual components that sit inside of an assembly. And we can then go and assign which of these components we're wanting to use as part of the nesting process. So we might have some components in here, like I do over here, that are fasteners, and I don't actually want to include them in the nesting preparation. So I can go into the option over here for the component type and say I want to ignore these components. Others, I've got the ability to then go and choose against each of the other components that exist inside here, and if we have multiple, like with the door over here, it will then go and apply it to all other like components inside of the assembly. We can then go and choose the component type, so whether it be a sheet metal component, an entity, a selected entity like we have here, or we're using the sketch. And based on the type that we choose from within here, this is what it's going to be using for the profile when creating the nested elements. I'll leave these others as automatic, but just while we are here, one other thing to point out is we've got the ability as well to go and choose the orientation of the grain if we wanted to along this way. So the orientation of the grain in our sheets that we're going to be adding our nesting to can then go and correlate to the grain on these elements as well. Once I'm happy with that, I'll hit OK on there, and then I'll head over to the manufacturing workspace. So in the design dropdown, I'll go and grab manufacture. And within manufacture, I've got the ability to go into fabrication as an environment. And directly inside here, I can go and create a nest study. So using the inputs that we've added inside of the assembly environment or in the assembly workspace, we can then go and create a study for the nesting itself. What this will do is it'll then go and take all of the individual components and try and match them to and sort them into the individual sheets of material. So in order to get that configured correctly, we would have to go and set up our process material library, whereby we can go in and assign different material packages from inside of the model itself. So I can go in here and I can say, well, I want I've got stock of a sheet that is about 2000 by 1000. It is rectangular and it costs X amount. When it comes to nesting, I want to enable left, right, or top, bottom trimming against this particular sheet. I've got the ability to go in and add other sheets as well by right-clicking and selecting add. I can go and create other packages from within here as well. And I can also separate these by material. So we've got a material and thickness, then we've got the sheet dimensions against each of those. We can also, as a package, rather than having a rectangular form, have a roll, and that will then obviously only require a width, but we can also go in and specify those from within. Against each material, we can also have a color associated to it, what its density is, what the material is, what its thickness is, and be able to assign any other variations against that. If we wanted to specify the packaging, we can come in and specify other packages that are available against that particular material, and then go that next step further and choose how that material nests. Are we wanting to allow items to rotate 90, 180, 270 degrees? What is the deviation against those? And so on. We can then also go and choose the material grain orientation, and that's currently set at a 0 degree going along the length. Once we're happy with that and got that all set up, we can then go and ensure that that is being used in our nest study. So using the nest study over here, we've got the ability to go and add any comments, choose how many instances of this we wanted to, how many jobs we wanted to do of this particular one, in case we want to increase the duplication of components, what the stack size is against these. When it comes to the shape, which components are we wanting to include inside of the shape itself, what their materials are, what their thicknesses are, and so on. And then from there, what packages we want to use from here. So it's gone in and grabbed, or it's gone in and added, because we didn't have oak available to us, it's gone in and added oak sheets with the length and width that we require against those. We could also go in and change the material against each of those elements if we wanted to as well. With the global parameters, we can choose where the cornering is located in case we want to go and maximize the efficiency of that sheet. And then the optimization of the remnant, we can choose whether we want to optimize the length or width, or try and minimize both the length and width as much as possible between those. Once we're happy with that, we can hit OK. That'll then go and generate that study for us, and we'll now go and place those together. So it'll go and place like for like in terms of thickness, and then sheet size as well. So we've got sheet 1 inside of nest 1, sheet 2 and 3, as well as then inside of nest 2 we have sheet 4 available to us, which is going to be the 2 doors, which are slightly thinner than the rest of the components. Once we've got that all set up, we can then essentially go straight from here into either a manufacturing model, or we could export the DXFs directly from inside here. So if we wanted to go straight into this and begin cutting and creating our cutting profiles, we've got the ability to just go straight into 2D profile. It's then going to go and grab all of the components. I can go and grab each of those over there, tell it to go and grab all of the edges of the components, the silhouettes of them, and hit OK, and that will then go and generate, once you select the correct tool, the components that are, or the edges of the components directly from inside there. So really quickly being able to go from an assembly model, being able to work out the most efficient use of the material, and then being able to go and produce the tool paths that will be required for that, or the DXFs as well that you might want to go and push out to a manufacturer or anyone along the way. And then the other area I want to go and focus, the last area I want to go and focus on, is some of the advancements that we've got inside of the milling environment within Fusion. So within base Fusion, we do have quite a lot of CAM functionality inside of it. So anything that sits pretty much within the 2D environment, and most of what sits within the 3D machining area is available straight out the box within Fusion. Where we do have some extra functionality is in some of the newer strategies that are available to us. So we've got steep and shallow that's available within the extension. We have deburring and geodesic. So deburring is just going to go along any of the sharp corners, sharp edges, and then just go nice and neatly go and neaten those off with a chamfer tool or something, just to make sure that we don't have any burrs left behind. Geodesic is going to go and trace along surfaces a lot better than some of the other strategies will, and actually going and tracing nice and neatly against the surface that we decide, rather than having to try and limit the area in which we're machining along the way. Opposite, I suppose, to deburring, we've got cornering, which is going to allow us to say, well, if we've machined using a particular tool, we know that we want to go and finish off wherever that particular tool wasn't able to reach. If we've got a larger tool that we wanted to use for big clear out and do a lot of roughing on the model itself, we then want to go in with a second tool and finish off any of the pockets, any of the corners that particular tool wasn't able to get to because it was a little large. So cornering is going to allow us to do that. The other options we have available to us within the manufacturing extension are the multi-axis functionality. So we have all the way up to 3 axes and turning inside of the traditional or the base Fusion installation, but anything 4 axes and 5 axes and beyond requires the manufacturing extension. And within that, we've got a few more advanced options available to us, whereby we've got swarfs, we've got rotary pockets, rotary parallels, and contours available to us. So using some of the models that we've got available to us over here in the list, I'm just going to open up this one over here as well very quickly. Using some of the tool paths that we've got available to us within the extension, again, one of those is our rotary option, and this is going to allow us to have simultaneous turning strategies available to us, so 4th axis, and allow us to vary the depth of the tool as it goes and rotates around your component. So we've got the ability to, using our rotary option over here, we've got the ability to choose between, if I go and edit this one over here very quickly, within the passes tab, we can go and choose the type of rotary options that are available to us, whether we're wanting to use a spiral, where it's going to slowly move back from either the front or back, from one side of the component to the other, or along the axes of rotation. We've also got line, which is then going to do a continual movement along the axes at slight increments, at slight indexes, and just slowly move up and down the surface of the model itself. Or we have circular, which is going to keep in contact with the surface as it goes along. If I hit OK on there now, we should see that then goes and regenerates quickly. And we'll see that these lines are all parallel to each other along the length of the component, but keeping in touch with the surface along the way. So we've got a few different options available to us when it comes to the rotary. So we've got any surface that needs fourth axis rotation, but you want to keep it continuously in contact with the surface. With any varying geometry, we've got the ability to go and grab that from within there. Within that as well, we've got the ability to set angular limits against that. So if we only want to machine a certain area or certain duration of that surface, we can also go into the passes themselves and set the limitations within there. Sorry, not within the passes, within the geometry tab. We've got the ability to set angular limits against that, and we can come in and adjust the surface areas that are going to be machined as part of this particular strategy. So we can set a start and an end angle. I hit OK on there, and that'll then go and regenerate the area that we are allowing the machining to take place in. So really quickly being able to go in and update those directly from inside of that. Some of the other options we have available to us as well is the ability to use rotary pockets. So anytime we've got any pockets that go all the way around a component, without this, we can do just single pockets and increment them along the way. What this will allow us to do is trace all the way around the component, all the way along a spiral. So any variation in rotation around the c-axis, or depending on your rotation of your axes of rotation, we've got the ability for it to then keep in contact again to that pocket surface and just slowly move around, almost like a contour that we would expect from a normal 2D strategy. So that's another really handy one that we've got available to us. And then we've got a newly added advanced swarf, which is going to allow us to go and pick edges and allow us to then tilt the tool away from any pre-existing geometry that sits inside of the model itself, avoiding any contact and any collision with your material, with the stock itself. On top of that, any of the or most of the other 3D strategies will also have some multi-axis capabilities available to them, and this is also then included inside of the manufacturing extension. So if I went to, for instance, we'll go and grab a contour. We've got, with the normal contour strategies available to us, we've got the ability to allow movement in a multi-axis direction. So if we do want to just use 3 axes, we've got the ability to keep that in there, but we can also use the same strategy, allowing us to go and treat any sharp edges or any steep surfaces, and be able to then tilt our tool just to be able to avoid any collisions with any other geometry. So we've got the ability to set a primary tool axis direction, and we can either say that it always needs to remain vertical, or we want to be able to come in at a bit of an angle, either directing the tool always to a particular point or particular line, or from a particular point and from a particular line if we wanted to go and machine inside of any pockets in that. So we've got the ability to go and set those up directly from inside there, as well as allowing some collision avoidance. So if it does pick up any collision within the model itself, we can avoid the stock, either using an automatic avoidance or again using a to and from point option or to and from curve option as well. We can also go and choose the tool axes limits as well directly from inside here, so the amount of tilt that we're wanting to allow the tool to use when using a 5 axes. So if we do want to make sure that the tool is always as close as possible to a 90-degree angle but within certain limitations, we've got the ability to set that against the most of the standard 3D strategies, predominantly the finishing strategies from within. And then the last area I want to take us through very quickly, I'm running out of time over here, is some of the modification options that are available to us. So in this headlamp option, this toolpath over here, we've got an untrimmed toolpath within this parallel. So using the parallel strategy within the component itself, it's gone and the way it's calculated these, it's gone and spilled over the edge ever so slightly. So what we've got the ability to use inside of the manufacturing extension are some of the modification options against the toolpaths themselves. So the two that we're going to look at here are the trim toolpath and the delete passes. Delete passes will allow us to go and delete single passes along the way, so we can come in and choose the passes that we want to remove. So if we do find that there's just one or two passes that we just don't want it to use along the way, say for instance those ones down here, I can go and grab those with a selection, maybe exclude those ones there, and any other passes that we think are going a little bit over the edge over there, we can go and remove them from the generation. I can go and hit OK on there now. It will then need to regenerate that toolpath, but it will then go and remove those passes from the toolpath itself. So we can go and remove individual passes rather. So any individual pass can be removed as and where we want to. The other option we have as well is the ability to trim toolpaths. So again, if we've got certain pockets that we want to completely avoid, using the trim toolpath option, we can come in and create any shape from the angle that we're viewing from. So in this case, if I view it from the top of my model, I can go in and either go and draw a polygon, which is going to allow me to go and draw a line or multiple lines connected to each other, to go and draw out a region that I want to ensure Fusion is ignoring. I'll then hit accept and OK the dialog, and Fusion will then go and regenerate that toolpath, avoiding anything that is within that region. So in this case it's just one little pocket over there, but if I decide actually I want to go from a very particular angle, there might be an angle that you know isn't accessible by your component itself, your machine itself. If you aren't using machine avoidance and all of that, we could go and say, well, actually from this particular angle over here, let's go and remove the toolpath, anything that sits within this region over there. And it'll then go and remove anything that sits within that region and not make contact with that surface there. So it might even be that there's a little bit of surface geometry that you want to leave for machining later on. It may be something that hasn't been added in there, or you just don't want your particular toolpath to go into that surface at that point in time. And rather than going in and sketching all of that geometry out to begin with, you can come in and use your trim toolpath just to say, well, that particular area for this toolpath we want to go and avoid, and we don't want to make contact there. So those are the extension options that are available to us. We've got the design, we've got the manufacture, we've got the simulation, as well as the signal integrity and the manage extension available from within Fusion. If you do want to discuss any of these in a bit more detail, if any of these have piqued your interest and you want to understand a bit more about any of them, or you've got any other questions, please do feel free to get in contact with us. Other than that, I hope you all have a great day further, and I'll see you all again in the next one. Bye for now.